on probability. Yesterday we talked about the basics of probability. Empirical versus classical is kind of a big thing. Like, if we roll a dice, we expect to get one out of 6 times. But we know in actuality, if we roll it 6 times, we are not guaranteed to just get a 1. So we talked about that difference. Today we're going to get into some more of the rules. So, your best friend, your formula sheet is very handy here. Under chapter 5, the first couple bullets are empirical and classical probability, and we're talking about that second column now. So, first we need a definition. Mutually exclusive, also known as disjoint. Those are events that have no common outcomes. They cannot both happen. Okay, Anna cannot be sitting in that seat and that seat at the same time. It's one or the other. It is impossible for her to be 2 places at once. So, mutually exclusive or disjoint means the probability of both. If it can't happen, what's the probability that they both occur? 0. Okay, there is no overlap here. If we have disjoint events, then we can find the probability of one or the other just by adding our probabilities. Okay, if I'm thinking about rolling my dice, if I want the probability of getting a 1 or a 2, can I get both a 1 and a 2 on the same roll? No. What's the probability of getting a 1? What's the probability of getting a 2? So if I add those together, 2 out of 6, or there's a 1/3 chance that I will either get a 1 or a 2. So, in general, or means add if we are talking about probability. If I want this or this, we're adding those probabilities together. So let's look at a problem. This shows the number of rooms in housing units in the United States. If I ask you to verify it is a probability model, what are the conditions to be a probability model?
Ask data.
And every probability has to be between?
0.
Okay, so I can quickly check that. They are all between 0 and 1. Alright, add them up, make sure. Does it add up to 1? So it is in fact a probability model. Okay, what is the probability a randomly selected housing unit has 2 or 3 rooms? Is it possible to have both 2 and 3 rooms? No. So all we have to do is take the probability of 2 rooms plus the probability of 3 rooms. What's the probability of having 2 rooms? 2 plus the probability of 3 rooms. So if I add those together, we get 0.125. Alright, what's the probability a randomly selected housing unit has 1 or 2 or 3 rooms? Is there any overlap there? No, so you just have to add all of them. 1 plus 2 plus probability of 3. So the probability of 1, 0.010, probability of 2, 0.032, probability of 3, 0.093. Get 0.135. not everything is, yes.
Could you put like all the parentheses in one?
Yes. Yeah, that's fine. So here's the problem. Not everything is disjoint. What if I wanted the probability that a student in our high school was in FFA or band? Can I just add the probability of being in FFA and the probability of being in band? What's the problem?
The whole story.
Okay. Are there students that do both? Yes. So those are not mutually exclusive because I would end up double counting those kids that are in both FFA and band. And that would skew my data. So if your events are not mutually exclusive, or still mean to add, but we have to subtract the ones we double counted. So if I did all the FFA kids and all the band kids, I have to subtract off those that are in both groups because I counted those people twice. That is our general addition rule. So let's look at this one. I showed all the outcomes if I roll 2 dice at a time. Okay? Do you guys know if you roll 2 dice, so there's 6 options on the first, 6 on the second, so there's 36 total combinations that you could get. I showed them in this diagram, but
So you just square the number?
you multiply them. So if I were going to like roll a dice and then flip a coin, how many options are there when I roll a dice?
6 plus 2.
You times it. And there's 2 options when you flip a coin. So there would be 12 different combinations that could happen. So if I'm rolling 2 dice, 6 times 6 is 36. If I'm rolling 3, 6 times 6 times 6 gives us 216, I think. So that's how that works. You multiply them. So E is the event. The first dice is a 2. F is the sum of the dice is less than or equal to 5. I want to find the probability of E or F. Now, because we have that visual, we probably could just count the ones, but let's kind of talk through it. So, is it possible that something could have the first one a 2 and they add up to something less than or equal to 5? Yeah, so I would end up double counting. So to find the probability of E or F, you have to do the probability of the first plus the probability of the second minus the probability of both. Alright, there are 36 combinations. So E, the first one is a 2. How many of these have the first dice as a 2? 1, 2, 3, 4, 5, 6 different combinations where the first one is a 2. Plus the probability of F. F is they add up to something less than or equal to 5. So 1 plus 1, 1 plus 2, 1 plus 3, 1 plus 4. Could I do 1 plus 5? No. 2 plus 1, 2 plus 2, 2 plus 3, 3 and 1, 3 and 2, 4 and 1, and that's it. So how many are there? Minus. How many of those dice did I count twice?
3.
These 3 fit into both groups, so I have double counted them. So I would have to subtract them off. So 13 out of 36 or 0.3611. Now, could I have just counted all the combinations up here and not done my double counting? Sure, but I'm trying to show you how the formulas work so that when you don't have the visual, you can still figure it out. Any questions on that one? Yes.
How did you just get the 3? Like the 3 over 36?
Oh, those were the ones that fit into both of these groups, where the first one was a 2 and they added up to less than 5. Alright, suppose a single card is selected from a standard deck. Do you guys know how many cards are in a deck?
It's easy.
Compute the probability of drawing a king or drawing a diamond. So I would probability of king or diamond. So if I'm looking at my formula sheet, the probability of E or F tells me it's the probability of the first plus the probability of the second minus the probability that it's both, because these groups are not mutually exclusive. What is the probability of drawing a king?
4 out of 52.
Right, there are 4 kings out of the 52 cards. Plus, out of my 52 cards, how many are diamonds?
13.
13. You could do 52 divided by 4 if you didn't know. There's 4 suits. There's 13 diamonds. Think 52 divided by 4 because there's 4 different suits of cards. Minus, how many cards are a king and a diamond?
1.
I'm subtracting him off because he got counted in both of these sets. Going okay? Let's look at this one. Alright. If I want the probability that a resident is male, what am I going to have to do first? Add them all up. Alright. I'm going to add up all my.
I think the difference is between divorced and separated.
They're separated, but it's not legally. Okay. So my grand total, I get 251.3. I add all those together. So the probability of being male, how many males are there?
22.
Out of how many total? And we get 0.4875. The probability a resident is widowed. What do I have to do?
Add the 2.
Add up my male and female. Out of the total. .0569. Determine the probability a resident is widowed or divorced. So my widowed is 14.3 out of 251.3 plus my divorced 25.4 over 51.3. What's 251.3? If I subtract the overlap, how many are both? 0. Those are mutually exclusive. You can't fall into both categories. So, we add those together. Yep, and divide by our 251.3. 0.15797, so 0.1580. It's because it's in millions, so it's 500,000. Good question. Any other questions? Determine the probability a resident is male or widowed. Alright, so we could do the male, or we've already found it, haven't we? So you could do the fraction, we could do the decimal, either way. So those are my males, plus my widowed, we said was 14.3. What's the problem though? There's overlap. So I need to subtract off the males that are widowed. Because I have double counted those people. And I get 0.5320. Is that okay? And the other piece that we need to talk about today, so I'm going to give you one more rule and then we're just going to practice these. We have also what's called complements. The complement is the opposite. So you might see it a couple different ways. You might see a little C as like a superscript there, or you might just see a bar over the top. Both of those mean the complement. It's just the opposite, so it's 1 minus your probability. So if I said, what's the probability, if I were looking at, what's the probability that a student is at school today? Okay. What's the complement of being at school? What's the opposite of being at school? Not being at school. If I add all the people at school and all the people not at school together, I get everybody. Okay, so if they're complements, if you know one, you can get the other just by doing 1 minus that value. So according to the American Veterinary Medical Association, 31.6% of American households own a dog. What's the probability a household does not own a dog? Right, either you own a dog or you don't. Can't be somewhere in the middle. So that gives us 0.684 or 68.4%. This data represents travel time to work for residents of Hartford County, Connecticut. What's the probability a randomly selected resident has a travel time of 90 or more minutes? So 90 or more, 48.95 out of, what do we have to do? Add them all up. That was annoying. I should have added this for you. compute the probability that a randomly selected resident will have a commute time less than 90 minutes. So I have two options. I can add all these people, or the complement of 90 or more is less than 90, so we just have to subtract from 1, and we get 29,876. Any questions here? Okay, last few, I'm just practicing manipulating our formulas. So I want you to be comfortable using formulas and solving for them like we would anything else. If I say the probability of A is 0.4, probability of B is 0.5, probability of A and B is 0.1, find the probability of A or B. That looks super confusing. But look at your formula sheet. Do we have a formula that involves both an and an or in it? Yeah, we said on our formula sheet it was E and F, but we can do A and B. It says probability of A or B is probability of A plus probability of B minus probability of A and B. That's our general addition rule. So plug in what we have. Do we know the probability of A or B? That's what we're trying to find. What's the probability of A? 0.4. Probability of B minus probability of A and B. We do that, we get 0.8. So when in doubt, write out your formula and plug in what you have. The next one. Trying to be sly and stand. If I were using that formula, what's the probability of A or B? Equals, what's the probability of A? Plus, what's the probability of B? Minus, I'm trying to find the probability of A and B. So solve this like any other equation. What would you do? So that would be a negative 0.2 divided by the negative. Probability of A and B is 0.2. All right, you guys try this last one. Okay, so use your formula. Probability of A and B. A or B is 0.9. Probability of A is 0.4 plus probability of B minus probability of both, which is 0.1. So combine my terms and subtract that over, so the probability of B is 0.6. So when in doubt, just write out the formula, right? Even if you're writing it on every one, it's okay. Then you can plug in and see where things go. All right, that's the end of this lesson. There is a handout